Music theory with Microsoft Excel. Analyzing inverted intervals. Get ready and some coffee because you ain't never seen rockin' unless you excel at rockin', and we're gonna Microsoft Excel the rockin'. We are in Excel. If you don't have access to this workbook, that's okay because we basically built this from a blank worksheet but started in a prior presentation. So if you want to build this entire worksheet from a blank sheet, you could begin back there or just construct the part of the table that we're building at this time. If you do have access to this workbook though, 4 tabs down below. Fretboard, example, practice blank. The fretboard tab having a simulated fretboard that we will refer back to. The example tab has the finished product, in essence, the answer key. The practice tab has pre-formatted cells so you could practice the practice problem with less Excel formatting. But if you don't have any of that, that's okay, because we'll be working in the blank tab where we built this from scratch from a blank worksheet, and we'll continue to build in the blank part of the worksheet going forward, practicing both our Excel skills and music skills at the same time. Let's go to the fretboard to get an idea of what we will be doing. We're looking at distance terminology, looking at the intervals, noting in prior presentations that we have some naming issues that kind of pull us out of the best mindset to be visualizing the fretboard. This time looking at inverse intervals, which compound the problems, also having their own issues. Best way to visualize the fretboard being the fretboard's a map of the territory, like the globe. We have 7 destination continent locations on the globe. The non-destination locations, of which we have 5, are like the oceans that we pass through to get to the destination locations. This fretboard having the low or heavy E string, the one closest to the ceiling on top. If we're looking down from space on it, like our head, above the fretboard, we imagine that it's rotating around in a circle like the planet rotates around, giving it 12 different scale degrees that we can view from our vantage point from space. And that means that this whole thing is shifting. We'll name those 12 views by the notes of the alphabet, A through G sharp, right? Or 1 through 12. And we're going to be working on the key of C, but note that if we're working in C sharp, the entire thing would shift to the right. Therefore, I don't want to name all the notes by the letters of the alphabet, but rather by the things that stay constant in relation to the shape that we're working in, that being the Nashville number system, which is basically the modes: Ionian, Phrygian, Locrian, Dorian, and so on and so forth. Now, the naming conventions pull us out of that because distance names are based on scale degrees. That causes us a problem that we saw in prior presentations that we addressed with how we would want to name the distances. Now, we have a different problem here. The problem is directionality. To understand it, let's recall the 2 main ways that we visualize the notes in our musical alphabet. One is like a number line or a note line where they go up onto infinity. Now, they repeat from an octave standpoint, but they are different. They're going to be increasing to infinity. Or 2, we think of a clock face where we're going clockwise around the clock, basically eliminating the concept of octaves, just talking about pitch. In reality, we would like to be able to visualize a 3D item where it's going up forever, but also spiraling up, so that we get both the concept of the repetition of pitch and the fact that it can go up forever. However, we also note that directionality is a thing under both visualizations, both systems. The number line, in other words, can go down forever as well, or from a clock face standpoint, you could go counterclockwise around the clock. Notice that our current system of naming doesn't really take that into account. So let's think about that for a second. If I'm on the key, if I'm on a C here and I want to get to the Locrian, I want to go to the IN modal range, then I could go up 11, which I can kind of cheat by saying there's 5 notes distance between these, 5, 10, and then 11. If I went up forward 11 steps, we would get to the Locrian here, or I can go back by 1. Right? I could go back to the 1 right here. So whether I'm talking about going back by 1 or up to the Locrian up this way, we usually think about that as an 11 note away major 7 distance from an interval perspective. So see how that's not exactly right, because you could see on the fretboard or on a number line or on a clock face that directionality wise I went back 1, I went lower a note. So ideally we would like to have direction, but the normal interval idea would be anytime I go backwards I have to name it with the inverse of it. So if I went from here to here, I'd have to say 12 minus 1 step back. I would still call it an 11 note away, basically major 7. So you could see it if I measure from this C to this G, for example, what's the distance? From the point of view of this C, there's a 5 note distance between these two, 6, 7. So it's a 7 note away distance, which would be a 7 note away perfect fifth from a normal kind of naming convention. But what if I went from this, I make this my point of measure, then it would still be 1, 2 plus 5, 7 notes away. But from this point of view, I can't say there's no term to say it's a negative 7 note away. I have to take the inverse, which would be the 12 total notes minus the 7 notes would give us a distance of 5 notes, and a distance of 5 notes would typically be called a perfect fourth. Now the 5 note away perfect fourth makes perfect sense when we're moving upwards on our note number line or clockwise around our circle. For example, if I'm on this G note, which would be the Mixolydian mode, and I go up in pitch by 5, which would be down towards the floor on the guitar, 5 notes between the strings, that would get us to this C or the Ionian, which is great. But when I go to this C, I'm actually going 1, 2, plus 5, or 5 notes backwards. That doesn't really make sense. Now the benefit, you can argue, is, well, if no matter what point I'm on, I can say that there's a defined distance to get to any other fixed point. So if I'm on the G or the Mixolydian, then I say I'm going to go a 5 note away, perfect fourth away, then I'm always going to get to a C or the Ionian mode, which is true, except that you're not actually going 5 notes away. You're going -5 to get back here. And that's really confusing, particularly on the guitar, because a lot of times people just give up on distance terminology, in part because they don't really understand how this inverse thing works, because in part it shouldn't be working that way, because you could see that distance and directionality are a thing. So guitarists just give up on it and they just work purely with shape. But you do want to still be able to count the distance. It's really helpful to be able to count out the distance. So we want to recognize that using normal terminology on a guitar, I can count the distance this way and get the interval by taking the inverse. Now later we'll talk about how we can add directionality in the terms for directionality. Some people might use, negative scale degree terminology. There's pros and cons to that, and one of the cons is that the inverse scale degrees don't make a whole lot of sense, because we started measuring at 1 instead of 0. In other words, if I measure, for example, from this Ionian to the Mixolydian, that's a distance of 5 between these, 6, 7. That would be a 7 note away, which we normally call a perfect fifth. Now the inverse would be 12 minus 7, or 5, but you would also think that if that's a perfect fifth, if the scale degree is 5 and there are 7 scale degrees, I should be able to take 7 minus 5 and get something close to the inverse scale degree. But I don't. I don't get I would get a 2, right? And what should the inverse be? A perfect fourth. So that doesn't make sense. I'd have to take 9 minus it to get there. Why is that? And that's because, again, the scale degree isn't the optimal terminology. We should be measuring the distance in modal half steps, and then we would get something that's going to work more of the time. In other words, it should be, in terms of scale degrees, not a 5, it should be a 7 note away, not perfect fifth, but fourth modal half step, right? And then I can take 7 minus 4, which would give us 3 modal half steps. See, that makes sense. From you would think the inverse would make more sense. Now, it's not going to be perfect all the time, but we'll talk more about that in a second. All right, so that's the idea. Remember our analogy here that we're imagining our continents. So this would be the position number 1 on the fretboard, where we're kind of mapped out the way we have our world mapped out. And so we're going to go North America, ocean, Europe, Asia, ocean, South America, ocean, Africa, Australia, ocean, and then Antarctica. If we put those in a circle, then we're going to make it look like this. So we're measuring our distance 2 different ways. 7 continents, continent to continent. We're only going clockwise around the circle. Notice again, you should be able to go counterclockwise directionally, but we don't typically name our intervals that way. So whenever I say I'm going from a 1 to the 5 nodal range, you can actually go backwards around the circle, but we always count it, we always name it as though we're going this way around the circle with regards to our interval names. So we're always saying this is going to be 1, 2, 3, 4 modal half steps forward, which would be the 5th scale degree, even though I actually went 1, 2, 3 modal half steps backwards to get there. Now notice it's not always going to be perfect that I can take the inverse distance no matter what, because there's going to be a different number of actual oceans, right, between the actual distance. So that's going to muddy up the waters a little bit, but we should be able to go forwards and backwards, but the conventional system always counts the interval as though we're going clockwise around instead of going, and we can't go counter, there's no terminology for going counterclockwise. We have to take the inverse for going counterclockwise. All right, let's get to our terms. I'm going to go back to our blank tab. I'm going to first unhide everything. So I'm going to select all the way across here, right click and unhide everything. All right, so now we can, what we've done thus far is we've taken our notes, all of our notes in our musical alphabet, 12 of them, and then we pulled out the collection of notes related to the key of C major. And so that's going to be these 7 notes. So that's our 7 notes out of the 12, our collection of notes in order, which if we start at any note within that collection, which will give us 7 modes, noting that the relative position of all of these notes will be the same for any key. If I did the same thing in any of the 12 other keys, it's all relative. It's all the same. It's all movable, copy and pastable if it was an Excel worksheet, for example. All right, so now we're going to say that our distances that we have, if we count our distances just going one way, if I start on 0 going up and we have 12 notes, then we can have a distance of staying where we are or up to 11 of our distances. If we're thinking about a circle, not taking into account octaves, which we'll talk more about in future presentations. So now let's add a column and say, well, we got to think about our inverse distance now. What's the inverse distance? So I'm going to add a column. I'm going to select, wait a second, let me unhide. Is there columns in unhide here? Okay, so I'm going to add a column between here. So I'm going to put my cursor on column K, right click and insert. So that's going to be our half steps. This will be the inverse. I'm going to actually add a column here. So I'm going to grab this whole thing. Let's grab this whole thing and pull it down a bit. So I have another, I'm going to grab it and pull it down. All right, so half steps. I'm going to call this an inverse distance. Hopefully I'm spelling this correctly. I'm going to double click up here. I'm going to make this whole thing black and white with the headers. Let's make this black and white. And let's center these guys. Center that. Okay, so if I'm going a distance of 0, the inverse is still just simply going to be 0. But if I go a distance of 1 forward, what would be the inverse? The inverse is always going to be 12 minus that distance. So there's 12 notes in the musical alphabet minus the 1 forward. So if I'm going 2 forward, then what would be the inverse? How many steps backwards would I have to go to get to the same point? So in other words, if I'm on let's see the C down here, and I'm going 1 forward, that would get me to the C sharp, and that would be equivalent to going 11 backwards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is going to get me to that same point. So you can see it from a number line that's going to repeat octave-wise in a linear fashion, as we see here, as well as you can see it in a circle. If we just wrap this around in a circle and you go clockwise 1 step, that means you can go counterclockwise 11 steps to get to the same point. So if I go 2 steps forward around the block, and there's 12 steps around the block, I can go 2 minus 12. I can go, let me do it the other way, 12 minus 2. I can go 10 steps counterclockwise. If I go 3 steps clockwise around the block, 12 minus 3 means I can go 9 steps counterclockwise. If I go 4 steps clockwise, 12 minus 4, which would be 8 steps counterclockwise. If I go 5 steps clockwise, 12 minus 5 would be 7 steps counterclockwise. If I go 6 steps clockwise, then it would be equal to 12 minus 6, or 6 steps counterclockwise. We're right in the middle. And then if I go 7 steps clockwise, then we're going to say this is 12 minus 7. That'll give us 5 steps counterclockwise. 8 steps clockwise equals 12 minus 8, or 4 counterclockwise, and so on. Now, obviously, this formula, I can copy it down. So I'm going to delete this, double click here. You can see it's 12 minus that number. So I'm just going to copy this down and say, and this could be, I could say this is 12 minus 0, meaning it's going to go all the way around back to the same point, right? All right. So that's going to be our inverses. Okay. Let me keep this at 0 because I think that might mess up my formula that I'm going to use later. That's what I have in my worksheet. So bear with me with that one. All right. So then what I'd like to do is say, all right, well, if this is going to be our inverse names, so we have the distances that we can name, the normal naming convention, a 0 note away perfect first, a 1 note away minor second, a 2 note away major second from the scale degree system, a 3 note away minor third scale degree, a 4 note away major third scale degree, a 5 note away perfect fourth scale degree, 6 note away diminished fifth scale degree, and so on. Let's now add the inverse of those. I'm going to select column O, right click and insert, and this will be the inverse. Okay, so now we're going to say, all right. Now again, I'm going to basically just keep this one the same because we're going all the way around the circle. And then if we went 1 note away, what are we going to have now? We're going to have an 11 note away if we go the inverse. So note-wise, it's going to be an 11. And what is an 11 note away distance? It's going to be a major 7. So it's an 11 note away major 7. So how can I basically, let me think about how I can, let's see if we use a fancy formula. This is going to be equal to an X lookup, let's say, and say that we want to find, I want to find this distance, and then comma, I want to find it in this array, and then comma, and then I want you to return the numbers in this array. And then I'm going to make this F4 absolute, F4 absolute, F4 absolute, and F4 absolute, so I can copy it down. This one is not absolute, so $ before all the letters and numbers, enter, and so there it is. So now it's pulling this one and saying it's an 11 note away major 7. Note here that the 11 makes sense, but then you just kind of have to know that it's a major 7. In other words, the 11 makes sense because if you take 1 step clockwise and there's 7 steps, that would mean that you would have to take 11 steps, 12 minus 1, to go counterclockwise to get to the same point. But then you just have to know that the 11 note away has an interval name of a major 7. And most people often just memorize the inverse without even thinking about the note distance, which is more difficult. You want to know the note distance and then know the interval name related to the note distance. One thing that's helpful to know, however, is that if you have a minor interval, the inverse will be a major, and if you have a major interval, the inverse will be the minor, and if you have a perfect interval, the inverse will be perfect. However, those are just kind of conventions. What you really want to know is what the actual note distance is for all of the intervals, and then you can easily determine the inverse note distance, and then you're going to have to know and be able to code switch between the note distance and the interval name. Now, the other thing that doesn't make sense is that it's a 7 here. Why doesn't that make sense? Because you would think if that 2 is a scale degree, and there's 7 scale degrees in the scale, then you would be able to take 7 minus 2 should get you something close to this number here, right? But that's not the case because 7 minus 2 isn't 7, right? You'd have to take something like 9 minus 2 to get something close to the scale degree, which doesn't make any sense. Why doesn't it make sense? Because the scale degrees are off by 1. We should be starting, it should be a distance term. So in other words, I won't do this for all of our distance terms over here, but just to get an idea, I'd like to be able to know the distance in relation to the node that we're measuring from. So a 1 node away is going to be not something that will land us on a continent if we were going from the Ionian or the Dorian, but it does on the Phrygian. So within the Phrygian, if I go 1 node away, then it would be taking me from the Phrygian node to the Lydian node. So I would call that a 1 node away Phrygian first modal half step, which would be the second scale degree. So you'll note that if I took 7 minus 1, then we'd get to a 6 modal half step. Now notice that it's not perfect here because the seven continents are different than the 12 notes, right? There's going to be a difference between the distance of the 12 notes and the 7 continents, but it gets you closer to what you would expect, and it will be correct in certain areas like on the perfects when you go a 5 note away and a 7 note away and you take the inverse. So in other words, if I go to an 11, we get to a 11 note away Phrygian 6.5. So the inverse isn't in the key, but you get something closer to what you would expect, right? It should be 7 minus 1, which gets you around the 6. So, right? It should. So that's why the inverse over here, again, the way the scale degree system is working doesn't really make sense from a distance perspective. You can see the inverse doesn't really make sense. Let's do the next one. So this would be, if I copy this down, so if we're saying it's 2 notes away, then the inverse is going to be 10 note away. So a 2 note away, major second. Major second means it's going to be a scale degree within the major key. The inverse would be 12 minus 2, which would be a 10 note away. And then I just have to know that that's a minor 7. Now, conventionally, I can say, okay, well, if this is a major, this is going to be a minor. But then if this is a second scale degree, you would think that it would be close to at least 7 minus 2. But no, it would be 9 minus 2 to get to the 7. So, which is weird. So again, if I took this 2 note away major second and I look at that in the Ionian, normally from a distance standpoint, I would call it a 2 note away Ionian first modal half step, right? Which would be the second scale degree. And so then you would expect that the inverse of a 2 note away Ionian first modal half step would be 7 minus 1, which would give you something close to 6. And you can see that you get something close, a 10 note away I 5.5. It's not going to be perfect because, again, there's a difference between the distances for the 7 continents than the 12 notes. But you get something that would be closer to what you would expect when you measure in terms of modal half steps than you do with scale degrees. You have to use this arbitrary number and say, well, it'd be like you're taking 9. You'd have to, for some reason, it's 9 minus, right? Which is kind of an arbitrary thing. And the reason it's an arbitrary thing is because it's not the way a computer code designer, an engineer would normally design the system. It's off by 1. It's not a measurement term. It's a scale degree term. All right, let's copy the next one down and say we're going to say this is going to be, if it was a 3 note away minor third. The inverse would be 12 minus 3, which would be a 9 note away, which I just have to know would be a major 6. Because this is a minor, I kind of know that that's going to be a major, but I don't really know that it's going to be a 6. How would I know that it's going to be a 6? You would think that I could take 7 scale degrees minus 3, 3, 4, 5, 6, 7, but no, you have to take 9 minus 3. 9 minus 3 gets you to the 6. Now, why 9? Because it's off. It's off. You would think, like if I look for a minor, let's look at a minor mode, which would be like a Dorian over here. You would think it would be a 3 note away, say from a Dorian, which would be the second modal half step, which would give us the third if we think about the scale degrees. Right, because then you would think the difference would be 12 minus 3 would be a 9 note away, and you would take 7 minus 2, 7, 6, 5. So it would be something close to a 5, which actually is in the key this time, a 9 note away Dorian 5th modal half step, which would be the 6th scale degree. You see, so again, I know this is more abstract to most people because you haven't seen that as much, but see, it's actually the way that you would normally think how distance should work. The scale degree thing is kind of not optimal. It comes out with wonky, weird rules that you have to put in, like you're going to subtract 9 all the time, which again is weird. Like why would that happen? Why would it be 9, right? That doesn't make any sense, other than you're compensating for the fact that the thing was off because you started at 1 instead of 0, right? So this one, if we say it's a 4 note away major third, what's the inverse? It's going to be 12 minus 4, which would be 8, and you could just need to know then that 8 notes away would be a minor 6, right? I can know that it's going to be minor because I know if this is a major, the inverse will be minor, but the 6 is difficult to note. You would think it would be 7 scale degrees minus 3 would give you something close to the inverse, but no, it's again 9 minus 3 gets you there. So if you looked at a major mode like an Ionian, we would say it would be a 4 note away Ionian second modal half step, which would be the 3rd scale degree. And there's going to be a 7 minus 2, 7, 6, 5. So you would think it would get you something close to 5. And it does, if you use, right, you would get an 8 note away Ionian 4.5 modal half steps because it's not in the key, right? Similarly here, because we can see it's not in the key. If it was a major, you're going to get a minor over here, oftentimes not, right? So this one will be because it's a perfect. So if I do this one, we're going to say, all right, this is going to be a 5 note away perfect fourth. What's the inverse? 12 minus 5 or 7 notes away, which we just have to know is a perfect fifth. It's useful to know that the perfects are inverses of each other. So the perfect fourth, inverse, perfect fifth inverse is a perfect fourth. But again, if I take the scale degrees, 7 minus 5 doesn't get you what you would expect. It's 9, or say 9 minus 4 gets you to like the 5. But you would think it would be something more like this. It would be a 5 note away Ionian third modal half step. 7 minus 3 would give you then 7, 6, 5, 4, which would be a 7 note away Ionian fourth modal half step or 5th scale degree, right? This would kind of make more intuitive sense. And so then we'd say, okay, let's copy the next one down and say this one's going to be a 6 note away diminished fifth. So again, this terminology is because it's diminished. It's not in the key, but it's not in the minor. So you had to call it diminished. So what's going to be the inverse? Notice it's also, in essence, the same because it's going to be right halfway down the line. So that one's a weird one. But the inverse is you would think it would be 7 minus 5. But no, it's 9 minus, you would think it would be 7 minus 5, but no, it's 9 minus 5. Is that right? To get you to 5. Actually, that would get you to 4, but it would be an augmented fourth. So again, even the 9 thing doesn't work exactly correctly. You would see this interval is actually in the Locrian mode over here. So if I was in the Locrian mode all the way to the end, it would be a 6 note away Locrian fourth modal half step, which would be the 5th scale degree. the inverse you would think would be 12 minus 6, which would be 6, and then it would be 7 minus 4, which would give you a 2. So you would think that it would be then a 6 note away. So 7 minus 4 is 3. And again, this is wonky. It's a little bit wonky, but it gets us closer kind of to what you would expect of the 4. But no system's going to be perfect as long as we're having two different measuring kind of systems. We're pulling out 7 notes out of 12. But it makes a little bit more sense. Let's go to the next one down. We're going to say this one's going to be a 7 note away perfect fifth. What's the inverse of a 7 note away perfect fifth? 12 minus 7, which would be a 5, which we just have to know is a perfect fourth. We note that the inverses of the perfects are themselves. So these ones get confusing, by the way, because a 5 note away perfect fourth and a 6 note away fifth, right? I'm sorry, the perfects are inverse. A 7 note away perfect fifth get confusing. These two get confusing sometimes. But so that's going to be it, but we just have to know that that's going to be a perfect fifth. Then if we look at it over here, I can see it would be a 7 note away Ionian fourth modal half step. Inverse would be 12 minus 7, which would be a 5 note away, and you would think the inverse would be 7 minus 4, 4, 5, 6, 7, which would be 3, which makes that one makes perfect sense, right? So now you have the inverse would be a 5 note away Ionian third modal half step, which would be the fourth scale degree. So that's going to be that one. If I copy this one down, and we're going to say, all right, now we have an 8 note away minor 6. So the inverse 12 minus 8 would be a 4 note away, which I just have to know would be a major third. Now I know that if this is a minor, this will typically be a major, but the third is weird again. How do I know it's the third? Well, it would be, you would think it would be 7 minus 6, but that doesn't work. I have to take 9 minus 6 to get to 3. But so you would think it'd make more sense if this was a minor. Let's look at a minor mode like the Dorian. This is an 8 note away minor 6. So let's say we're on actually let's look at the Phrygian, because the Dorian is weird on that interval. So if we're on the Phrygian, it would be an 8 note away Phrygian fifth modal half step. So the inverse would be 12 minus 8, 8, 9, 10, 11, 12, which would be a 4 note away. And then you would think 7 minus 5 would be 2. And that's close because it's a 2.5. Again, it's not going to be perfect because the inverse is out of the key, but it makes a little bit more sense of what you would expect. And then you're going to say this is going to be a 9 note away major 6. What's the inverse? 12 minus 9, which would be a 3 note away minor third. You just have to know that 3 notes away is a minor third. We know that it's going to be a minor because this is a major, so you can kind of know that by convention. But the 6, you could say, again, it's not 7 minus 6. You'd have to take 9 minus 6. If I look at the major 6 on the Ionian, I would call it a 9 note away Ionian fifth modal half step, which would be the 6th scale degree, right? And then the inverse you would think would be the same of 12 minus 9 would be 3, but then 7 minus 5. So 5, 6, 7, which would be 2. So it'd be a 3 note away Ionian 1.5 because it's out of the key of Ionian, right? And so so let's do the next one. A 10 note away minor 7. Inverse would be 12 minus 10, or a 2 note away, which I just have to know is a major second, but I can't take 12. 7 minus 7 doesn't get me to that 2. I have to take 9 minus 7 to get me to the 2, which it kind of works, but it's totally kind of arbitrary. And so if I looked over here, let's look at like the Dorian, where you have a 10 note away Dorian 6th modal half step, which would have an inverse of 12 minus 10, or a 2 note away Dorian 7 minus 1. You would think it'd be around the 1, and it would be a 2 note away Dorian first. That one happens to be in the same key. So then we're going to say, let's do the last one here. The inverse of an 11 note away major 7 would be 12 minus 11, or 1 note away, and then you just have to know that that's a minor second. Again, you can kind of know that the major has an inverse of a minor, and you can't take 7 minus 7, but you can take 9, just arbitrarily know it's 9 minus 7, and then you have to know that it's going to be, a minor. So that, again, the conventions kind of work, but they're wonky because you would think, because they don't make sense from a normal measurement standpoint, because you would think if it was an 11 note away Ionian 6 modal half step up, then you can take the inverse would be 12 minus 11 or 1, and 7 minus 6 would be around the first modal half step, but it's out of key, right? So in the Ionian, so it'd be a 1 note away Ionian 0.5 because it's going to be out of key. The inverse is out of key. So again, they kind of shoehorn these to work if you use like the shortcuts, right? You use a 9 to look at the inverse of a major is a minor, the inverse of a perfect is a perfect, and you kind of memorize all those little conventions, but the conventions are arising out of kind of an error, in my opinion, and I think from a normal engineering convention of how you would build the system if you had everything at your fingertips right now, which is that we started at 1 instead of 0 with the scale degrees. So that scale degree system is making it so we have to take 9 minus the scale degree to get the inverse, which is totally arbitrary. That's weird because it's a distance location. And all these little weirdnesses work but they're more complex, and again they kind of pull you out of the idea that of the simplest way to view the system. Now, these inverses, again, you kind of have to see these so that you can get the proper terminology when you're going, a negative distance. But again, they're not exactly right because you would think if you go a negative different distance, some people actually use the term of a negative scale degree. So in other words, if you're in a major key and you go up 1 node, they're going to call that a 2 note away major second. But if you go back 1 node, you would go -1 back, which from a scale degree standpoint would be a negative second, right? A -1 second or something like that. But conventionally, we would call that as though we were going forward, an 11 note away major 7. So we would really like to use a term, again, going backwards other than the inverse would be useful because, again, directionality is a thing. And so we'll talk about possibilities to do that and how we can basically see that those convert that or bridge that to the terminology of an inverse term.